Thank you very much, and welcome to my presentation. I'm Lia Bertran, and today I'm going to present to you this talk about creating web-ready QGIS plugins, and specifically insights from Giswater for effective QWC2 compatibility. Before starting on what all this project is, first a bit about myself. I'm Lia Bertran Roca. I'm a student from Barcelona. And I've been working for Vigeo, a water utility developer company that basically is the main developer of a software, an open source software called Giswater. I don't know if you're familiar with Giswater, but Giswater is basically a tool for water network management so that water companies can better manage their networks, and well, it has plenty of different tools that, well, can help with that. And in Giswater is the starting point of all this journey. Basically, in Giswater, we found out that there were many clients that needed something, well, I don't know if needed, but may benefit from a lighter weight version of Giswater. Giswater, at the end of the day, is a QGIS plugin. QGIS is a heavy program that only works on desktop, so having a lighter version of it in a web, for example, was very useful, and that's where this journey began. And yeah, basically a lighter version of Giswater for field operators, and well, in general, just friendly software for people that are less technical, and using QGIS maybe a bit too much. So with this in mind, and before I talk about how all this journey went, let's talk a bit about the underlying technologies that we used, how everything works. First of all, a bit of background about the different technologies, as I said. First of all, QGIS and QGIS plugins. Just so all of us are on the same page, QGIS plugins and QGIS, well, especially QGIS plugins, are developed using Python. I believe they can be developed also using C++, but in our case, in the case of Giswater, is developed using Python. So in this case, this is how it works. And also for the user interface, for the UI part of things, the forms, the dialogues, it uses Qt. The whole QGIS is based on Qt, and Qt is the way we implement all the extra functionality, all the extra, not functionality, but the visual parts of the functionality. And these Qt forms can be created in two different ways, mainly using the API, the Python API itself in the plugin, just to dynamically create these widgets, or with a Qt Designer form. I believe the software is called something like that, Qt Designer, which basically is a UI, so you can very easily create with a user interface and very, I don't know how to say, but very end-user-friendly way of creating these dialogues and these widgets. And this is for the QGIS plugins part. Now let's talk about the web part. In our case, we went with QWC2. QWC2 is the QGIS Web Client 2. It's basically the official implementation of QGIS on web. It basically uses QGIS Server as the way to display the QGIS projects itself. And it's basically a website developed in React JavaScript as its front end, and Python as its back end. There's no specific set way of developing plugins for QWC2, but as it's developed in React JavaScript, the power of React JavaScript is, in my opinion, the composability and very easy to create new extensions. So it's just as easy as creating a new file, a new module, a new, what's the name? I forgot. A new component for React JavaScript, and then you just can add it to the main QWC2 website. And the same with the backend. It uses Python Flask microservices, so it just is as easy as spinning up a new microservice with the software that you need, and it's easy to go that, it's ready to go that way. So apart from this, the last piece remaining of the 3 main pieces of this project is Giswater itself. Giswater, as I said, is a QGIS plugin for helping with water network management. But the QGIS plugin part of it is, I would say, the least important part of the project. The software is mainly a huge PostgreSQL database that includes, of course, all the network, all the information of the pipes and nodes and inventory in general of the network, and also bundles with the same database all the functionality. This way, we can just ask the database for different functions to execute. An example would be if we want to calculate, I don't know, for example, the reach of the different, how long, if there's any, I don't know, let me think of an example, a good example. Yeah, for example, if you need to calculate if the hydrants are positioned good enough so that they reach the, I don't know, the reglementary way of placing hydrants. As you can see, I'm not an expert in the GIS part. You would just ask the database would make its calculations, and you would get back the result. We've made it this way because at the end of the day, the data is already in the database, and there are many, many, many good tools to develop these algorithms in the database. Of course, PostGIS is one of them. PG routing is another of them that we are heavily investing now in moving all these algorithms to PG routing, because at the end of the day, a network of pipes is just a graph. So traversing graphs and all these kind of algorithms go very, very well with our system. So yeah, as I said, to recap a bit, Giswater, main thing is the database, which contains all of the main functionality, and the Python part of Giswater, which is the plugin itself, is just a way to interact with this database and display all the information using these Qt forms and these, well, all these systems. So, with this in mind, let's begin the journey that we had. First of all, let's recap a bit about the problem itself. We wanted to port this plugin itself, which is the Python part of the database, because the database is already a database. We don't need to port it to anything. We need to port this QGIS plugin to a QWC2 plugin. So how did we start? First of all, UI in the database. This seems a bit of a crazy idea, and maybe it is, but it works very well to this specific use case. And it was something that was already built before this project in Giswater itself. Basically, in the database, when you ask for one of these processes to be executed, as I said, this reach of hydrants process, or just creating a visit, or many other things, the database not only returns you the result of this operation itself, it also returns you some widget information, basically which widgets should be shown to the user. This way, for example, in the case I explained about, for example, visits, a visit is basically just if some field operator has gone and checked a pipe that was broken or something like that, you can make a note and note it, and it goes to the database. So when you ask the database to, hey, I want to create a new visit, the database will return you, of course, the usual information about what's the new ID of this visit and the basic information, but will also return you a list of fields that the user needs to be shown. For example, an editable text that is the description of the visit, a button that when clicked would open a dialog that would allow you to upload files, so it can be, so you can post pictures of the visit and how it went, something like this. All of this is stored in the database so that it's very easy, later it's very easy to just call these functions, get what you need to display afterwards, and just display it. This also really helps with customizability, because different clients have different needs and may have different fields on their network. They may have different, well, each client is a different story. So yeah, having this ability of the user to just do whatever they want, change what they see, what they don't see, hide different tabs, show different tabs, have new functionality. Well, functionality, maybe not functionality, but yes, but definitely so more information. They allow the user to completely customize everything that is going to be shown, even the position of many things. And this, as I said, this system only returns the widgets that need to be shown, not where they should be shown. It has some information about where they should be shown, but not specific information about the layouts itself. An example would be, this is a very good example about what happens when you click on a pipe or a node or something, an element on the map. This dialog would pop out with the information of that specific element. This is the template that we have built in Qt Designer. As you can see, it's just empty. It has all the layouts, but it has no data itself. The data comes, of course, from the database. This layout may be called layout data 1, and this may be called layout data 2. And in the database, each widget says in which layout it goes. So basically, we have the widget of, I don't know, which node it's connected would be in the layout N, layout 1. So then, when the Python receives all this data, just puts it in the correct place. This is how Giswater worked for a long time, and what really enabled us to make this move from desktop to web very much easier, because everything is already dynamic. Well, everything. We had to do a lot of work for everything else that wasn't like this dynamic to become dynamic, but the idea was there, and we could just use this idea to build up and have a different system, a different pipeline that used this system to work on the web. So yeah, this is basically the UI in the database part of the equation. The next part is how do we create the form itself. Now, that, as I said, to a bit of a recap, we ask the database for a specific process, a specific information, and you don't only get the information itself, you get how the user should see it, which fields, which widgets should be shown to the user. Now we need to take all this information and create a visual and like something like this to be able to be displayed to the user. As I explained already how it works on desktop, and I'm going to explain how it works on web now, what we've developed. And it is this concept of Qt Forms as a service. It also sounds a bit ridiculous, but it works, so we run with it. Basically, we had a decision to be made. QWC2, as I said, works with React JavaScript as its front end and Python as its back end. And we had to make a decision on where to put all the logic to transform this list of widgets into a viewable and actually functional and interactable thing. Of course, it's web at the front end always has the responsibility of drawing things for the user. You don't have that much screen real estate, especially if you are in mobile, and we are targeting that kind of use case because field operators and, well, we're at the end of the day, that's what we want. That's why we have web. So we have a different set of templates that work best for web, but at the end of the day, just have the same information, layouts and where should they be put. And basically, how it works is, if you remember prior, I talked about how do these Qt forms work in essence. They are basically just XML code. It's just an XML file which contains all the information about all the layouts and all the widgets and where they are in in the well, in the form itself. So what we have is this Python just handwritten. It writes plain text XML from the data that we have. Similar to how the QGIS works, that the QGIS plugin works, but without the powerful API that QGIS itself provides, because at the end of the day, we are in a standalone Flask instance existing in there, so we don't have that many tools. At least we think that's something we are working on, but probably we don't have that. So we just, at the moment, just create the XML itself by hand, literally just as strings, which maybe it is sounds a bit wrong, but at the end of the day, it just, maybe you miss a quote somewhere and just tells you an error and you fix it and that's it. And this is the extent of the issues that you get. So it's not that bad to work with. So basically, to recap a bit this part, you get the list of widgets from the database, and the this Python backend takes all of this information, creates the XML, which is basically a Qt form, fully filled with all the information that is needed, and sends it to the front end to be displayed. So now we need a way for the front end to have and read this XML and render it as HTML. Thankfully, and this is the last part of this whole adventure, thankfully, in QWC2, there exists something like this, an XML to HTML, well, React HTML, both things at the same time, and exists an XML to HTML parser that is already built in, that has been developed, that it's basically, I think it's used for the attribute form feature of QGIS. I'm not an expert, I think it's that way. You can create custom Qt forms that can be displayed. And in QWC2, they've implemented this feature as well. So when you open an attribute form, it can render all these Qt forms, which of course are written in XML to the user. So we took this and implemented our own logic on top of it, because of course our use case was a bit more extreme than just displaying information to the user, because of course if you go past showing information to the user just when clicking on an element, you need to implement a lot of logic of editing, for example, which is a big pain in the ass, because you need to take all the values of the widgets, and when you modify them, then send it back to the database and get back the updated HTML or XML. It's hard. There are some I don't know, some flows, some paths of code that are very hard to reason about. But at the end of the day, when we have a very talented team of engineers that we put a lot of hours into this, and it's doable, and we did it, and it's now working. So we're very happy with the results. And yeah, it works very, 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 very good, in my opinion, at least. And so yeah, this is the last part of the puzzle, having all this XML and being displayed to the user, and also including the functionality. So basically, something I think I missed from before, something that is very important is that as much of the logic of the widget itself, the interactability of the widget is also described in the database. Because, for example, when you, a button in a widget, for example, that could tell you to, an example, you open information for an arc, for a pipe. There are two buttons that send you to the connecting two nodes, that open just the information about the connecting two nodes. This is described in the database. In the database, there's a parameter that says what happens when I click this button. And what it says is just a string saying open node with the ID and the parameter which needs to be called, And then when everything goes back to the front end, this tag, this what happens when I'm clicked, gets transferred to the front end, gets to read it, the React JavaScript gets to know about this, and just has an easy check that, okay, if the function that they want me to call is open node, just open another information with the ID that they passed. And that's how it works. And it's very important to have as much as information stored in the database so that when it goes back to the front end, the interactions are very easy, and especially trying to avoid as much hard coding of the logic, because if you hard code the logic, then when you try to port it out to the desktop or from the desktop to the web, you get so many issues. We had to deal with so many issues while porting the QGIS plugin to the web. You cannot imagine the amount of heads, like hair-pulling lines of code we had to debug and try and figure out what they meant so that we can port it back to QWC2. So yeah, this is basically the architecture, just a bit of a recap. Database, you ask the database for some process to be called, so it just sends back the result of that process or the information that it needs, plus what user interface, what UI elements should be displayed. Then this would be sent to in the desktop side would be sent to the QGIS plugin, and they would display it as usual. But in our case, it's sent to our Python backend that just builds this XML and sends it back to the front end, in this case to QWC2. And QWC2 just takes this XML and all this functionality explicitly written in the XML and displays it and makes it interactable. So yeah, this is basically the whole architecture. A bit of going forward, things we have planned, because this is very much not finished. It's in production and it works very well, but there are some things that could be definitely improved. For example, a better way of creating the XML. We decided to put all this logic of creating the XML on the Python side instead of the JavaScript side, because it's the same language that the QGIS uses. But we're not able to use the same libraries that QGIS uses because we're not in QGIS. But maybe if we figure out a way of doing it, which we should be, I don't understand, I cannot think of a way why we couldn't. Maybe it's just as easy as reusing most of the code that already exists in the QGIS plugin itself, just reuse it in the server side and just transform these dialogues into XML and send them back. And well, there's a few more things about some things we should be improving, but I don't think it's very relevant to this talk. So yeah, and that's basically it. Thank you very much, and any questions you have, I'm glad to answer.